air source heat pump. So I know this is obviously very, very big in your market. So general overview real quick, I'm sure you guys are well aware of how it works, but essentially using that same DX system that you'd use for cooling to now reverse the flow of refrigerant and use it for heating. So essentially we're changing our evaporator and condenser coil and just flipping the purpose of those so that in heating mode, we can reject the hot gas from that compressor to that indoor coil and heat up that cold air that's coming in. And then just grab the heat. Even though it's cold outside, we can still grab heat out of that outdoor air. Benefits or advantages, obviously high efficiency. So we're focused on higher efficiency, which means lower operating costs. You can see Seattle in there as an example versus your typical indirect gas furnace. And then also you have a lower carbon footprint. So you're seeing a lot of initiatives, electrification movements across the country to make sure that we have a safe and clean alternative to that conventional heating with that indirect gas furnace. So extremely important that you take advantage of these air source heat pump benefits, but there are some challenges with this as well. So heating performance is directly dependent on the ambient outdoor temperature. So one thing that happens is efficiency will decrease as your outdoor temperature decreases as well. So as an example, I have a true DOAS unit. This one does not have energy recovery. You have 2,500 CFM, 100% outside air. At 47 degrees, so a mild condition when I still need some heating, I have enough capacity to get all the way up to 90.3 degrees leaving air temp. As my ambient temperature drops all the way to 17 degrees, which is normally where we're sitting at, that's a mild condition for Wisconsin. But if we're at 17 degrees, we have a heating capacity of 82 MBH. I can only get up to 47.4 degrees. So the benefit of a furnace, you always knew what your temperature rise was if you had a consistent CFM. Didn't matter what the entering temp was. In this case, you can see I go from a 43 degree temperature rise down to a 30 degree temperature rise. So my capacity and efficiency is decreasing enough where it's directly impacting the overall temperature rise that I can get. So that is really where secondary heat will come into play. And that's that first bullet point you see. Efficiency, if it drops enough, certain climates, those colder climates, are going to require a secondary heat source to make sure you can satisfy that discharge temperature set point requirement. The other things that you have to look at is, are you in an area where your heat pump is going to lock out? So typically an air source heat pump cannot operate below 0 to 10 degrees outdoor temperature, depending on manufacturer. Another thing you'll have to look at is there's certain indoor coil entering air temperature requirements as well. So it's not just ambient. Sometimes it's in conjunction with some minimums entering the indoor coil. But that could be another reason why you would need a secondary heat source. And then lastly is that defrost mode.